Here I have another one in front of me. How about a nutcracker, a lever? What happens? I put the nut in here, and then easily accomplished, effortlessly. Here's one for the housewives and the boys and girls and the mothers and fathers and the school teachers. A broom. A broom, I regret to say, is a lever. And next time you sweep the house, I wish you would have some regard for Archimedes of the 3rd century B.C. And I'm going to show you how the lever can be used in an enchanting way. The usual way is what? We hold it there and push here, push here, push here. The fulcrum here and the force there and the load down there. It can be used in another way. Watch me. I'm going to have the fulcrum here and I'm going to push it here. Not too handsome a way to use a broom, but it can be used as another class lever. More on the same. If indeed the subject is getting, let us say, monotonous, it should not be. All these things are levers. Here is a piece of metal. Here a little pair of metal clippers. I have difficulty. Why? Not enough lever arm. Not enough lever arm. A larger shears, effortlessly. There it is, like cutting butter. Or consider a file. What is a file? A file is a succession of inclined planes. And regarding a file, I hope sometime you will be able to go to Milan, Italy. And in the Museum de Leonardo da Vinci, there are many of Leonardo's devices, and one of them is his file maker. And when I was there last, I used it and made, indeed, some scratches on a file. How about a meat grinder? Oh, nobody uses a meat grinder much these days because it's done for you. But if you will look inside, you will see that that is an inclined plane. Beautiful there. The camera catches it nicely. Here it is. Here's one of the cutting tools from inside, and you see it is an inclined plane. How about an egg beater? An egg beater. An egg beater is not a simple machine. An egg beater is a compound machine made up of a lever, the handle, and some geared wheels. And what do? We turn the geared wheel. There is a certain number of notches on the big wheel and a certain number there. The handle is so long, and so we speak of the mechanical advantage of a simple machine. Meaning what? How many times is the force multiplied when we apply a force? If, for example, with a force of 1 pound I can lift a ton, then the mechanical advantage is 2,000. Let me go further. Here is an interesting thing. Pulleys. Pulleys. Now it is very important that I say something about pulleys. When students and boys and girls study pulleys, it is usually said that to find the mechanical advantage of a pulley system, you count the number of ropes supporting the load. Now, I should say that this is not a good thing to do. It sometimes leads to the right answer, but often the right answer is gotten by physically wrong means. And this is a very important philosophy to remember. Getting the right answer is the least important of your endeavors. What must be right is the logical, analytical reasoning that leads to it. So I would urge you to study pulleys and learn how to find the mechanical advantage without counting the number of ropes. Here is a pulley system made up of 2 blocks with 3 sheaves each, or 3 pulleys each, rather, and I can lift an enormous force by the application of a small one. Notice, friction is not playing an adequate role, and so the system unwinds. And when I talk about pulleys, what name in history must come to my mind? Answer, Archimedes, because you remember he designed all kinds of machines of war in order to protect the city of Syracuse against the invasion by the Romans. And I would urge you to read the story of this great adventure as recorded by Plutarch. The siege of Syracuse by Marcellus, the Roman general. Where am I now? Where am I? Oh, let us take some ordinary cutting pliers. What is a cutting plier? Well, we say it in the plural, pliers, wire cutters. First, it's a lever. Secondly, it's an inclined plane because the cutting jaws are inclined for sharpness. And ever so effortlessly, I cut a wire. And so, ladies and gentlemen, and boys and girls, we come to the end of this program, indeed to the end of this 15th program, and what has been my singular ambition throughout the series. It has been just this: not to teach you any physics, not to assign any lessons or any problems, but rather to point up the beauty and the drama in all of this and to excite your enthusiasm and your curiosity. For these are the foundations which will lead to your better understanding. Now, what have we done? What do physicists do? What is physics? What is science? That's an all-embracive term. Science, of course, is what scientists do. Physics is what physicists do. And what do physicists do? Physicists explore how nature behaves. And I urge you to spell that nature with a capital N. So as you go about your daily affairs, your school days, your days at home, your playing hours, I would urge you to have a regard for the things all around you, for they are filled with beauty and drama. And seeing how nature behaves will give you a full life. And I thank you for listening.